Hi ladies and gentlemen, welcome back to my channel. In this video we are diving into Docker Pro techniques that make your containers faster, smaller and way more secure. From lean builds to tight security and smart image management, these are strategies every serious Docker developer should master. So without further delay, let's deep dive into the action. Master multi-stage builds. A multi-stage build is a single Docker file that contains multiple from statements. Each from instruction begins a new stage of the build. We can selectively copy artifacts from one stage to another, allowing us to separate the heavy build time dependencies from the lean runtime environment. For instance, for this Angular application, I'll try to build two images using both single-stage and multi-stage Docker file. Then I'll try to run them in order to compare their performance in real time. So for that purpose, I'll copy my path. Then I'll open new terminal. I'll navigate to my path. And then I'll start by the single-stage image. So I'll type docker build -f for file specification, which is gonna be docker file dot single and then -t, and for the name it's gonna be angular -single, and then we simply add dot at the end and I'll press enter. Alright, our angular single image has been created, so I'll try to run it in a detached mode. So I'll type docker run -t and then angular single. Alright, so our Angular single is running, and I'll basically try to rename it to Angular single instead of the proposed Docker name. So I'll type docker rename the container ID and then the new name, which gonna be Angular -single. Alright, so I'll do the same for the multi-stage image. So I'll start by building it. So I'll type docker build -f docker.multi then -t angular dash multi and then space 2. Alright, the image has been created, so I'll also try to run it in a detached mode. So I'll type docker run -t -name equal angular -multi and then our image name, which is angular -multi. Alright, so right now our Angular single stage and our Angular multi-stage containers are running. So right now I'll start by comparing them. So first I'll compare their image size. So I'll type docker images and I'll also capture a snapshot showing a live stream of the container resource usage statics. So I'll type docker stats and then no stream. So as you can see guys, the multi-stage build is roughly 5 times smaller than the single stage build, which make it faster to deploy and easier to manage. It's also incredibly efficient. It uses virtually no CPU compared to 2.39% for the single stage container. In terms of memory, it's about 4 times more efficient, running on just 18 MB of RAM versus 84 for the single stage version. On top of that, it operates with less than half the number of processes, which significantly reduces system load. All of this highlights its superior efficiency across every key metric, making it the clear choice for lightweight, resource-friendly deployments. So to conclude with multi-stage builds, we create smaller, faster, and more secure images by separating build dependencies from the final runtime environment. We only keep what's essential, cutting out compilers and extra tools to drastically reduce image size. This not only improves security by minimizing the attack surface, but also speed up image pulls and deployments, giving us a linear, more efficient Docker workflow. Leverage the dockerignore file. A dockerignore file works like a .gitignore and tells Docker which files and folders to skip when building an image. Using it makes builds faster by excluding large or unnecessary directories like node models or .git. Improves security by keeping sensitive files such as .tmv out of the image and reduces the build context, which helps Docker use its cache more efficiently for quicker rebuilds. For instance, this is a great Angular.docker ignore file that efficiently excludes node models, build outputs, test artifacts, environment files, IDE settings, and Docker related files. It keeps the container lightweight and secure by only including what's necessary. Choose and pin your base image strategically. In production environment, we must never rely on the default latest tag for our base image, as this choice forms the critical foundation of our container's security and stability. To optimize this, we always select a minimal distro-less base image, such as Alpine variant, since these are stripped down to only the essential dependencies our application needs to run. Furthermore, it's imperative that we pin our image to a specific version tag, for example Python 3.14.0-Alpine 3.22, to guarantee an identical and reproducible environment across all builds and to prevent unexpected breaking changes from automatic updates. Finally, we always source our images from trusted providers such as Docker official images, which are vetted and maintained to adhere to the highest standards of security and quality. Run containers as no root users. By default, containers run as a root user, which creates a significant security risk for our environment. If a malicious attacker breaches our application, he effectively gains root level access inside the container, providing a dangerous stepping stone to host level exploits. To secure our infrastructure, we must enforce no root users and adhere to the principle of least privilege across all our deployments. For instance, for this fast API project, I am running a Docker container without specifying a no-root user, so we can see it in the CLI. So we'll simply type docker ps, and that's it. So we can execute command inside it using docker exec. So we'll simply type docker exec -it, and then our container name, and then sh, and I'll press enter. And I can verify the user privilege using whoami command. And as you can see, it's root, so I'm capable of installing any dependencies. So we'll try to install nano. So I'll type apk add nano and I'll press enter. So as you can see, the dependency has been installed, and basically I'm capable of accessing any sensitive data inside the container or modifying existing files. And obviously this setup poses security risks such as privilege escalation and data exposure. So in order to mitigate that, I have to add a no-root user. So I'll back to Visual Studio Code. And after the last copy command, I'll start by creating a no-root user and group. So for that purpose, I'll simply type run add group dashes up group, which is our group name, and add user dash capital S up user, which is our username, and dash G to specify the group, which gonna be up group. Next, we will change the ownership for our working directory to our new user and group. So for that purpose, I'll simply type run shown for change ownership -r in order to recursively change ownership for the parents and child files and folders. Then I'll specify the user and the group. So I'll type up user colon up group, and then our working directory, which is /co. Finally, we will switch to no-root user using user up user. Alright, so after setting a non-root user inside our Docker file, I'll back to the CLI. And inside the CLI, I'll try to build our non-root user image and run our container. So for that purpose, I'll simply type docker build -t fast API no root user and then space dot. Alright, our new image has been created. So basically right now we'll try to pause our previous root container. And I'll try to run a new container using our fast API no root image. So I'll type docker images and I'll copy fast API no root user image and I'll simply type docker run dash name equal fast API no root user and then our image name and I'll press enter. And as you can see our container is running. So I'll try to test it and execute command inside it. So we'll type docker exec dash it and our container name, which is fast API no root user and then sh. I can see user privilege using who am I command. And as you can see, we are having a no root user called up user. And I'm expecting that I'm not capable of installing new dependencies, so we'll try that. So type apk add nano and I'll press enter. And as you can see, it has returned permission denied error, which means that we have successfully added a non-root user and provided extra security for our containers. Use immutable version tags for your own images. To ensure consistent behavior and predictable deployments across all environments, we should use immutable version tags for our own images instead of the mutable and ambiguous latest tag, which can reference a different image tomorrow than it does today. We address this by tagging our images with a specific immutable identifier, such as semantic versioning. This practice guarantees absolute reproducibility for our deployments and provides a clear rollback targets if a new deployment fails. In conclusion, adopting immutable version tags for our container images is the best practice that enhances the reliability, traceability, and stability for our deployment process. It ensures that every environment runs the exact same images, simplifies debugging and incident response, and fosters confidence in our release cycle. By committing to this, we lay a solid foundation for continuous integration and delivery, ultimately supporting more robust and maintainable systems. Enforce container resource limits. Containers share the host machine's kernel and physical resources. Without boundaries, a single misbehaving container can consume all available CPU or memory. This creates a noisy behavior problem that can starve other critical services and potentially bring down the entire host. For instance, in order to limit my Nginx container resources to a single core and half gigabyte of RAM, all I have to do is to type docker update CPUs equal 1 and then memory swap equal 512 megabyte, and we also need to set the memory to 512 megabytes. And finally, I'll add my Nginx container name, which is Nginx. Alright, our Nginx container has been updated and we can see that using docker stats. And as you can see guys, the memory limit is set to 512 megabytes. So basically that's it for our video. Thank you guys for watching, and if you have enjoyed it, press the like button and subscribe to the channel, and see you soon.